In this module, we're going to cover dictionaries, and we're also, just like with arrays, going to look at how for-in loops are modified and can help us in working with dictionaries. So in this, we'll cover, again, 5 different sections. The first is what a dictionary is. The second is why do we need them? So what advantage do they have? How do we declare them? How do we operate on them? And then again, the for-in construct and how it's modified to work with dictionaries. So let's consider the following. So let's say we want to create a single variable that holds someone's first, middle, and last name. So that seems reasonable. We want to print out their first, middle, and last name on separate lines, and we want to do that in Swift. So how would we do that? So again, break up into teams and have teams work on a solution for this. Once they've done that, they can present their solutions, and then I'll show you at least one of the solutions that might work, and we can then use that as the example for why dictionaries are an advantage. So here's a potential solution. In this case, we have this variable called astronomer, and we are actually making it equal to, or we're giving it an assignment. And notice we're using an implicit declaration here, so we're not telling it the type. It's implicitly defining the type because we have the left and right bracket, which means it's an array. And since all of these elements are strings here, it knows it's an array of strings. So we have astronomer, and we've given it the first name, the middle name, and the last name in our list, if you will. And so we now have a single variable that has first, middle, and last name. And then if we want to print each one of those out separately, we then have astronomer 0, astronomer 1, and astronomer 2 for our prints. And again, just to reinforce from arrays, we always start counting at 0, right? So this is the 0th element, this is the 1 element, and this is the 2 element. 0, 1, and 2, 0, 1, and 2. Count of the whole thing is 3. There are 3 elements in it, but we always refer to them 0, 1, and 2. So what are the problems with this solution? So can anybody think of, what seems a little weird about it? So one of the things I'm hoping is that when you look at these indexes here, these indexes really don't tell you very much. So you're reading the code and it says astronomer 0. Well, what is 0? I mean, 0 is just the 0th element in the array, and it's just by convention that we've decided that that first element is going to be the first name. And so 1 is referring to the middle name, but it seems very loosey-goosey as to whether this is going to be consistent and useful going forward. And I'll give you an example. Let's suppose we've decided that the requirements change a little bit, and we also need to record a title with a person's name. So in this case, our astronomer has a PhD in astrophysics, and so they are a professor. So what we want is Professor Carl Edward Sagan, and that is their name now in this list or in this array. But the problem with that is that now element 1 no longer refers to the middle name. It's now referring to their first name because we've added this additional element in front of it. So the 0th element is the title, and then the first element, or index at 1 being the second element, but at index 1, is not the middle name anymore, it's now the first name. And so this sort of illustrates the confusion and why this is not a good solution, because if this changes in any way, all of this code actually breaks. So here's another one. What if we change the order in the array? So now we're going to say Professor Sagan, and then it's first name, middle name. So if that is title, last name, first name, middle name, again, all of these no longer refer to what we think they're supposed to refer to, and they change. So now when we shorten this to Sir Isaac Newton as an example, element 2, which previously was the first name, is now referring to the last name. So this is not a good solution to the problem. We don't want this. What we do want to do is look at dictionaries. So dictionaries are going to come to our rescue and help us out here. So let's take a look at a dictionary declaration and see why this is better. So here we have a variable called astronomer like we did before, but we have some additional things that we've defined in our dictionary. So let's go through that. First of all, we are defining a set of keys. So the keys are how we index elements in the dictionary. So we remember with arrays, the way we got to elements in the array was referring to the index number 0, 1, 2, 3, 4. It's an ordered list. That's how we get values out of the array. With dictionaries, we don't use numbers. We use strings. Basically, these strings are going to be unique and they should be descriptive, and then they will give us a way to index into the dictionary. So for the dictionary here, we have keys of title, first, middle, and last. And then every key has a value associated with it. So given the key title, we have the value professor. Given the key first, we have the value Carl, and so forth. So it is keys and values, and the way we identify each of these is with the comma here at the end, very similar to like we did in an array where we have all the elements in the array. We're going to do the same thing with dictionaries, but then we're also identifying the difference between the key and the value by putting a colon in between. So we have the string here, the colon, and then it just so happens this is another string on the other side. That could be any type, which we'll see in a second. But that is basically a dictionary. It's a key value pair where we get an element of the dictionary by referring to a key here. So key value pairs are associated with dictionaries, and that's how we address and set and get data from dictionaries. So now when we look at the elements of our print statements, we're no longer saying 0, 1, 2, and 3. We're actually saying the key that we want it to reference, which is really nice because now when we say title here, first, middle, and last, one, it reads very clearly. We can see absolutely that that's what we're going to get back from it. And the way it's going to come up here and get that data is by looking at these keys. So for example, let's suppose that we change the order of how we declared things in here. That would not change or have any effect down here. So we could redeclare middle up here, first here, and last here, and this would still work. The order change would not matter. The other thing that's interesting is as long as we don't reference it, if we remove something from here, so we remove the reference to the middle name, let's say we decide that we didn't want to track that or use that, as long as we don't call it down here, again, title first and last, all still work. There's no difference, there's no update that we need to do. This code is always going to work, even if we remove some things from the dictionary. So keys are always going to be strings when you think of dictionaries. And the thing to think about, though, with this is that they must always be unique. So for example, we have title, first, middle, and last. All of those are unique strings. They are not equal in any way. However, if I were to, in the dictionary, try to do this, where I would declare the key middle and Ed and the key middle and Edward, these two match, and that is illegal in a dictionary. So when I have a key and I go into the dictionary, it has to be unique or not there at all, but you can't have a duplicate. You can't have 2 or 3 or 4 keys that are all the same in the dictionary. And then the values can be whatever type you want. The only thing to consider there is the type has to be consistent as well. So in this case, we're consistently having strings here, but those could be integers or whatever we wanted. And they don't have to be unique. You could have the same value for 4 different keys. It's just the keys have to be unique and the values just have to be the same type throughout the dictionary. So in this case, if I was creating a dictionary of famous constants, if you will, well, we have Earth's gravity, pi, and c, which is for the speed of light. All of these are the keys. They're all unique. They're all strings. That's all valid. And instead of strings over there, here we have doubles. or floating point numbers, and that's what we have for our values. And again, that's fine as long as they're the same all the way through. So how we declare a dictionary in the formal sense is we say var astronomer, in this case the variable name, colon, and then we give it the description of what the dictionary's keys and value types will be. So it looks like an array, but the reason it's not an array, it's a dictionary, is because we have the colon in between. We have a colon in between these two things. If this was just a left bracket and a right bracket with a string, it would be an array of strings. But because we have left bracket, right bracket, we have two types here with a colon in between, this means it's a dictionary. And again, this doesn't have to be string. This could be another type. This is almost always a string for the keys. So in this case, a double. Here we have a string for key and a set of doubles. There's one other thing I want to introduce you to with respect to dictionaries, and it's a new concept that is actually best explained and introduced using dictionaries. It is a different module, so we're not going to cover the whole concept here, but I did want to just introduce you to it because this can happen for you when you're using dictionaries. So when we look at this declaration right here, and we look at this print statement, we see right here that it has a key that it's going to address. So it's saying it wants to print out famous constants. The key is pi. It sees pi in here. And so we would think that 3.1415 is what it should print. However, when we actually do this in the playground, we get this warning message here. And notice down here, when we actually have the printout says optional and then the number in parentheses. And the warning is actually saying that we are implicitly coercing a double question mark, which basically is implying that we're coercing an optional to be an actual value. What the heck does that all mean? So essentially, the reason it's doing that is because we can't be guaranteed that every key that we might put as a string that we want to check for is going to be in the dictionary. So for example, let's suppose I misspelled this and I had put PIE here. Well, PIE, although it's pronounced the same way, pi, is not the same as PI. So when the computer goes to look up pi in the list of keys, it doesn't find it. So this is an attribute of dictionaries that's not really true of arrays. So when we go into a dictionary with a key, it may not come back with a value because that key may not be defined in the dictionary. So in this case, if we look at this in the playground, we see that we have pi here and we have PIE versus PI. And notice down here, we're actually printing out nil, and nil means nothing. It's the same as null, nil, nothing, empty. You can kind of think of them all as the same thing. In Swift, we call it nil, and it means that we were not able to come up with any value for that particular key. What that means is that the result of looking up a key in a dictionary is essentially referred to as an optional. An optional means that it may or may not come back with a value, and that will be all dependent on the circumstance that it's used. This is really not true with arrays. For example, here, if I use the index of 2, as long as I haven't exceeded the count of the array, I am going to get back a result. These are not optional results. But it is not the case with dictionaries. Basically, they may or may not return a value based on the key that we've supplied there. And therefore, we have to return an optional every time, and the optional is either that it has a value or it doesn't have a value. So in this case, we would be returning nil because we're asking for the middle name in a dictionary that doesn't have middle as defined for a key, and so we return nil in that case. Now, the final thing I want to cover is just iterating through dictionaries using the for-in. And so there's a way to do this very easily, and that is we can change the variable that we put here. Instead of giving it a variable name, we can give it really what's referred to as a tuple. We haven't really covered tuples, but you don't need to really go too deep into them here other than to understand the syntax. We just have an open paren followed by the word key, comma, value, close paren. And you should use those names for your variables to keep it clear, key and value, because that's your key value pair for dictionaries. And then we're saying in our famous constants. So we're looking at key and value for each of our elements in our dictionary. And then we're printing out the key and printing out the value. And so this is a very easy way to iterate through a dictionary, is you basically can use the for-in loop, you name the dictionary here, and then you put this key value syntax at the beginning. That's going to, inside this for loop, give you access to key and give you access to value, and it will give you each of the key value pairs in your dictionary. Now, dictionary attributes have a few other attributes as well. So for example, when we talked about arrays, we said that it had an attribute called count, where we could say, hey, array, how many elements do you have in it? Well, it turns out that for dictionaries, it's very similar. You also have a count, except it's the number of key value pairs that you have. So in this case, if we said count on famous constants, we would get back a value of 3. It would be 3 different key value pairs. But we can also say, hey, dictionary, give me all the keys that are in the dictionary. So we can do that by saying dot keys, and that will give us the key for the first, the second, and the third key in the dictionary. And then for values, here we can say we are going to get the 9.8, the 3.14, and the 186,282. Those are the values associated in the dictionary. So we always have this ability to do keys and values for attributes of dictionaries. So that summarizes dictionaries. Essentially what we did is we covered what a dictionary was, we covered why do we need them, we covered how do we declare them, how do we operate on dictionaries, and finally, how do we use the for-in loop construct to iterate through the dictionary.